So what we're going to be working on is another trinomial, factoring this trinomial. The steps are still the same, but the difference here is that the leading coefficient is not 1. Everything we did yesterday, the leading coefficient was 1 after we took out the greatest common factor.
Miss Deborah, what number are you doing?
I'm on 21. It's on the back side of T2. I
Got it.
You found it?
Yes, ma'am.
All right. All right. So the first step that we're going to use here, like I said, the steps are exactly the same. We're going to look for a greatest common factor. Now, the shortcut that I gave you yesterday to look for the greatest common factor was if the leading coefficient was 1 and there was no variable at the end, then the only greatest common factor was 1, and we ignore that. And then today and yesterday, we talked about if I want to try to find the greatest common factor, I gave the steps yesterday and in the video before that. But what we talked about yesterday is if I'm looking for the greatest common factor, I look at the smallest number, the smallest coefficient. And if it will divide into these, then this is the greatest common factor, okay? But 2 will not divide into 7 and 2 won't divide into 3. So we do not have a greatest common factor. Now understand, when I say that we don't have a greatest common factor, we always do. The greatest common factor is, yes, it's an invisible 1, but we ignore that because it doesn't make any change. So I've taken care of looking for greatest common factor. If I'm looking for a special, it only has 2 terms. This has 3. Groupings, 4 to 6 terms. Nope, there's only 3 terms here. So I'm going to go straight to 2 parentheses. Now, when the coefficient, the leading coefficient, is no longer an invisible 1, then what I call this factoring is trial and error. Okay, there is another process to doing this, but it's a little more involved, and for GED, I don't think you need it. Okay, if you want to see that, let me know. All right, so the rule is still the same. The front times the front will give me the front. Okay, and the only factors is 1 and 3. Okay, so it has to be a 1. I still need the x and a 3x. Y'all see, 1 times 3 gives me the 3, and x times x gives me the x squared. You see? So we're still doing what we've always done. And we still box in the center term. We'll come back to that. Then we still find the factors of the back, because I need the back times the back gives me the back. Okay? And so I've got 1 times 2, and the next one is 2. So this is it. Now, this is where it comes into trial and error, because I can put the 1 here and the 2 here. But remember when I told you it really didn't matter where these go? Now it matters, because they're going to be multiplied to different front numbers. I'll show you what I mean. Let's do the test again. And I have 3x. And I have 2x. And I have to have a positive 7x. Will the 3 and the 2 ever added or subtracted? Will it ever give us 7? Okay, this is our trial and error. Apparently, I put these in the wrong place. Now, you don't juggle everything, just switch the back numbers. Okay, and we'll try again. So we put the 2 here and the 1 here. Now we'll multiply again and get the 6x and 1x. And sure enough, All I have to do is add these together. Now, am I adding positives or am I adding negatives?
Positives.
Positives. So both of these have to have positive signs. Don't write the 1. So this would be our answer right here. This is the complete factoring of this polynomial. The reason that we had to do the trial and error is because in this case, we can't find a set that will make 7. We have to actually try them out. And if they don't work, then switch the back ones until they work. Okay? It's not much different, do you think?
No.
Okay, let's try another. Are there any questions on this one? No?
No, good.
All right. We may just go on to 22, or I may skip down and see if I can find one. Let's go to I'm trying to find one. I'm picking one off of T3 because I want to show you something that might come up. And again, I'm trying to find one. Yeah, let's do this. We're going to do 27 on T3. 27. This is the exact same thing. The reason I picked this one is because when we're finding factors of the front and factors of the back, there are more than one set to choose from. What did I say?
27.
27. I went to 21. It didn't look right. 29. No, it doesn't look right. 4x squared. And it's not even Monday. X plus 24. All right. Now, first of all, we have to look for the greatest common factor. Now, the greatest common factor, the biggest one that it could possibly be, is the smallest number, okay? So I look at the 4. Will the 4 divide into 35?
No.
That already screwed it up. So it can't be 4, but 4 can divide by 2. So let's see if 2 is the greatest common factor. So 2 will go in here. Will 2 go in here?
No, not evenly.
No, again. So there's not a greatest common factor. Now, just a review to finding the greatest common factor for you all is do a t-chart, factor tree for each one. This is just a review. If you go back to the YouTube videos, there's an explanation for this. All right. And the way that you find the greatest common factor is you have to find a number that matches in each piece. Like, let's try a 2. There's a 2 here, and there's a 2 here, but no 2 here. So I can't use that. These are all 2s. There's a 5 here, but no 5 and no 5. There's a 7 here, but no 7 and 7. So that's telling us that the only greatest common factor is our invisible 1. Okay? Be sure and go back to the YouTube video. It tells how to find the greatest common factor. We did several examples on there. Since there is not a greatest common factor, it doesn't have 2 terms, doesn't have 4 to 6 terms, we're going to go to the 2 parentheses. Because the leading coefficient is not the invisible 1, we know there's a possibility that we're going to do some trial and error. So I need the factors here. 1 times 4, 2 times 2. So I'm going to have to use one of those sets in the front. This is 1 times 24, 2 times 12, 3 times 8, 4 times 6, 5 won't go, and then there's 6. So this is all of them. Again, you are not able to just look at the set like you could before to get 35 because you're going to be multiplying the front times something. So it's going to be a trial and error. My suggestion, I need to decide the front times the front gives me the front. I'm going to have to decide which one to use here. Now we don't know. So the rule I go by is what was the main multiplication fact that you learned in the 3rd grade. Mine was 2 times 2. I know 1 times 4 also, but this was pretty common. So I'm going to start with that and try it out. So 2 times 2 gives me 4. X times x gives me x squared. Okay, so that's what I'm going to try. Now I'm going to go to the back. I'll skip here, go to the back. And I don't know which one to use here, but I'm going to use the most common for me is 4 times 6. Okay, so now I try this out. I have 8x here, 12x here. And that's not going to give me 35, is it?
Nope.
Now, if I choose to switch the 6 and the 4, I'm still going to be multiplying each one of them by 2, so that's not going to change anything. So 4 times 6 doesn't even work. So I'm going to try something else. I'm going to try 3 and 8. And in actuality, I don't know what the answer is. So here's 6x, 16x. And again, switching these won't make any difference because they're still going to be multiplied by 2. I am thinking, now what you would usually do is go through the next one and the next one. 4 and 24. And 48 minus 2. Let's try the 1 and the 4. Is that what you were suggesting?
Yeah, probably, because none of those are going to make it 35.
I agree. Oh, so I have decided I want to switch and try the 1 and 4 on the front. One and 4. Now, we were working here. So let's do the 8 and the 3, okay? This is 12. This is 8x. Is that going to make our negative 35?
No.
No. But since these are different now in front, we can try switching these. And so now I have 32 and 3. Okay, aha. If I just add these, I get 35, right? Now I'm needing a negative 35, still adding. So do you see that these are both negative? If I have to add 32 and 3 to get 35, but it's negative, then I'm going to have to make both of them negatives. And here, finally, is the answer. Now, I have to be perfectly honest with you. The other process that I learned, and actually I learned it just a couple of weeks ago. I'd never seen it before. It takes away all of this, well, what if this works? What if this works? What if this works? It tells you the answer straight up. So if any of you want that, feel free to ask and I will explain it. Okay.
Yeah.
So we've done 2 of these. How many of you need another example? Another example. Got it. Do I have questions from my remote students?
No, I'm still good.
Okay. Is that
Thank
you,
you.
Shaniqua? Somebody just came in. I thought I saw somebody. Oh, no, it's Sandra. Hi, Sandra.
Hello.
Okay, today, Sandra, all we did is we reviewed what we did yesterday, and you were getting that perfectly fine. Today, we are reviewing the problems that are on the back of T2. I'm sorry to hear about your son. I hope he's not.
He's okay, but I won't be able to take him to the doctor until 2, so.
Okay. Well, this works then. So
Yeah.
what we're doing is showing you how to factor these problems that don't have the invisible 1 for the
Okay.
leading coefficient, okay? And I call it trial and error. Now, I showed you some of this yesterday, Cindy, right? So
Yeah.
we're reviewing this, okay?
Okay. Mhm.
I'm going to work number 28 on the back of T2. Okay, our first step is to look for a GCF. And what I have told you is this is the largest that we could possibly use. The smallest number is the largest that we could possibly use. And so I want to see if 2 will divide into 9. It won't. So the only GCF we have here is the invisible 1, and we don't use that. So we don't have special because special has 2 terms. We don't have a grouping 4 to 6 terms. And so we go to the 2 parentheses that we're going to factor this into. Remember, when these are crammed together, it means times. It's an invisible times in there. So what we're going to do is the front times the front gives me the front. Now, there are several things that make 9, several factors, 1 times 9 and 3 times 3, okay? And there's only 1 set of factors here, 1 times 2. So I know 2 is going to go in the back because that's the only thing we can. Which one do you want to try here? I
3
say
times 3.
times 3. Okay, and then I have to have the x times x. Don't forget those. Okay, and now we try it out. 3x, 6x, and I need a negative 9x. So what do my signs need to be here to add these together to get a negative 9?
Negative.
Both
Good.
negative.
Have to be negatives. And here is your answer. Ta-dam. Our first time through. It's kind of nice. Any questions here?
No, ma'am.
Sherry, how do you feel?
I'm okay.
Okay. And you're going to be staying on afterwards like you usually do, right?
I might stay on a little while.
Okay. Sounds good. Josh, how do you feel here?
Oh, pretty good.
Good. I'm so glad that you're recovering also and in physical therapy. Yay.
Yeah.
Okay, well, I'm finished for today unless you have questions. You're welcome to stay on, but I'm going to stop the recording now. You can stay on the Zoom as long as you wish.